All right, it's almost 2, so I think we should get started. Good afternoon, everyone. I want to start with thanking you guys for being here, because you see, it's a Friday afternoon, post-lunch, last session of the conference, and we're going to be talking about troubleshooting web apps, right? You see, nothing's working in my favor, so I really appreciate you guys being here. Thank you very much. All right. So with that said, we're going to talk about today, well, first of all, my name is Apurva Joshi. I'm a program manager on Azure App Service team. I focus on building features for web apps. I spent the first half of my career with Microsoft working as a support guy. So I've seen the pain customers go through when things don't work out very well. And one of the things that I decided when I took up this job to try and do things where I can help improve situations for the scenarios where you have deployed the sites in production, it's running full-blown, and something's bad's happening, right? And now you really want to find out what's going on. What can I do to troubleshoot and things along those lines? Because there are tons and tons of solutions out there that basically go and say, I'm going to give you alerting. I will monitor this application for you. I will let you know when something goes wrong. Great, you get a phone call, you get a pager. What's next, right? That's when people start usually freaking out. The page is loading slow. I don't know what to do next. So what we've done here, and especially with the Azure Web App Service, is an attempt to try and automate the diagnostics to a point where we can start trying to give you a snapshot of what is happening in a production site at any given time, along the side with the prescriptive guidance on what we think is going wrong. Because most of the time, for the developer, you don't have to tell him what to and how to fix it. You just tell him what has been screwed up, and he or she knows what to fix it, right? So with that said, we're going to go ahead and start the session with this. You guys know the usual drill. Please go ahead and submit the eval because it helps us improve. And the agenda basically for this, and the key takeaway I want you guys to go away from there is to understand the tools and the best practices available to troubleshoot Azure web apps or Azure websites or app service, focusing on the performance and availability issues. And the reason it's very important because the Azure App Service is sort of a fully managed PaaS solution where we don't allow you to RDP. We don't allow you to install a bunch of tools, right, and things along those lines. So that makes troubleshooting a little bit of a challenge. And basically what you should be doing when all the tools and everything else doesn't work, what the next options are, right? Okay. So we'll just cover the 4 to 5 topics at high, which basically what could possibly go wrong. We'll see all the situations or different kinds of issues. So we try and identify and categorize the issues before we start diving into how to use certain tools, because it's important to understand what kind of issue you're seeing before you start using different tools, right? I mean, you don't want to use a sledgehammer to try and put a nail to a fence and things along those lines, right? So we'll see the tools that are available. We'll do lots and lots of demos. In a demo, I'm going to start with something very, very simple. We'll walk through how do you start peeling the onions until in the final demos, we'll start looking into some really, really advanced stuff and see how we can help you troubleshoot live performance issues with your websites. It's not going to be like I'm going to open up Visual Studio and attach a debugger and put a breakpoint to my production site. It never works, right? So we want to see and show you what do you do in a situation when all those known tools available to you don't work. And we'll take a lot of questions. Hopefully we'll have enough time for that. So what could possibly go wrong, right? It's always a question on everyone's mind when you're running it under a very tight deadline of shipping a product or shipping a site, things along those lines. I experience that every single time. And when I was making this presentation last week, my wife came and told me a little nice story about my 2-year-old and what happened. And I thought it was fantastic to share that with you guys because it helps you or helps us understand different kinds of issues and whatnot. So here's what happened, right? Last week, my 2-year-old at his preschool had a session to take a picture with his classmate, right? So my wife is all excited like any mother. She wants the picture to be perfect, my kid to look very fantastic, right? She dresses him up, and she has a picture in her mind that's what this picture should look like, right? So this is what she's preparing for. The one in the head is my little one. So she's picturing in her mind, this is how it's going to be, right? I'm going to prepare this this thing in a nice way. And it's usually a very nice kid. Like, I want to think of him as a very well-written web app, right? He's a good kid. And my wife is trying to go through this process of getting this picture done, right? So she's running late. All of a sudden, kid started crying, and she's freaking out. She's like, oh my God, the picture's not going to look like this. He's crying, right? This is a typical thing. I want to ship a product. I'm running out of time. So she decides, you know what? In the car, I'm going to give him a candy. It always works, right? So the kid gets one candy, and he's a little happy, but he's using the situation to his advantage, and he's like, I want more. She goes like, yeah, I'll go and give him another candy. What can possibly go wrong? It's just a candy, right? So she gives him a candy. Third one, right? The kid's all happy. He's all stoked up. He's ready for the picture, right? It's all good. She shipped the product. And this is what the picture turns out to be. You see the guy, little one, he was sitting next to his best friend. In the next frame, both of them, they were on the floor, right? So this is how it turned out to be for in that situation. I thought it's very similar to how we do development and how we do agile development, start pushing things into production and things along those lines, right? And at the end of the story, I asked her, what would you tag it as a root cause? She goes, obviously, it's a sugar, right? I gave him too much sugar. Such a nice guy. It's a very well web app. I gave him too much sugar. That's what caused the issue. If I were to ask the same question to the victim's mother, she's going to say, no, it's that boy, man. He's a very naughty boy. The boy did that to my son. If I were to ask my boss near what's the root cause, he's probably going to say it's a teacher. They should never make them sit together for the picture, right? So it's all different perspective and how you troubleshoot things or put things into perspective, right? So it's very important to understand the type of the issue before we start jumping at the issue, into the root cause. So every time you call into Microsoft support or any live service support or any company, there's at high level, there are 3 different kinds of issues that we go through, right? So here, you pick up a phone and say, right, well, we got a problem, right? First one is the most easy one. It's a generic FAQ, right? Or you want to do something like subscription migration. I want to move my asset from this subscription to another one. There is no SL impact. Everything's happy. You pick up the phone, you say, hey, man, how are you? How's the weather? I want to do this. Everything ends very happy most of the time, right? Perfect. The second one is you notice something crazy happening with your website, and you go like, hey, man, this is weird. And I don't know what to do about this. So you pick up a phone, you call support, and you report an issue with incident, right? So, and this category has 2 kinds of issues. The first one is usually an application issue, but it's very difficult to isolate. It's an application issue or a platform bug, right? So you basically go through a whole cycle of working with the board, trying to get the data, trying to analyze, and at the end of the day, okay, where's my dev? I need to fix this, right? And a lot of cycles been spent. It has an SL impact, but it's specific to you. The other category here, you repeat the whole cycle. You call, you go through the process, and then the support guy tells you, you know what, we found out there's a bug in the platform that's impacting you, maybe tens of other customers. The entire service is not down. And then customer usually goes like, okay, where's the fix? When are you going to ship it? And things along those lines. This is the second category that you see is the majority of the issues that support or any service usually goes through. The third and the big one is, oh my God, there's a platform issue, right? And usually the oh my God is coming from the service team itself. It's not usually the customer, because we have tons and tons of alerting and monitoring in place where we ping our SLA sites. There's a canary sites running on every single VM. We'll try and see what the response time is and the failure and things along those lines. We get the alert. And we start freaking out when we get the alert from any given stamp or region and have our engineers up and running. Usually it doesn't come from a customer, but there are situations where this might be reported from a customer because our monitoring didn't catch it. Nobody's perfect, and that's the learning process. We try and incorporate that into our learning process. This last category, there isn't much you as a customer can do to actually resolve the issue in most of the cases. You're basically at the mercy of service owner to try and fix the issue. All you need at that point is just tell me what's going on, how long is it going to take to fix the issue, and that's that. Let's go over what causes usually the platform issues as specific to Azure App Services, because we're built very unique way, right? Like Scott Hanselman likes to say, right? He when he talks about these different computes, he says, IaaS is like a building your own house. PaaS is like a renting the house. And app service websites, it's more like renting a luxury hotel, right? I mean, basically everything's there for you. You start using it. You can leave when you don't like it and things along those lines. So when we built this luxury hotel, it was basically using all the core services. Like we are dependent on SQL Azure. We depend on storage. We depend on network. We depend on cloud services. We're actually the largest cloud service out there on Microsoft Azure platform, right? So as you can see, any of those components can go wrong or have an issue, and that will impact our service. We do have built-in bunch of abstraction level on our system to basically stay aware and try and avoid those issues. But things can go wrong. Plus, we're deployed globally. It can be any stamp or another. There could be random bugs, right? So these are some of the things that could cause the platform issues, and there isn't much you can do, except for just going to this famous dashboard and try and see what the status is. And I'll be honest with you guys, right? I mean, right now this dashboard update is performed by humans, right? So you saw that large chart of platform issue where we get the alert. Somebody says, oh my God, freaking out. He gets on a call. He starts looking into the issue. And the next thing he does, he calls the dashboard guys, say, update this. Basically say, I'm having XYZ effort, right? And we're working towards automating this whole experience. But that's what it is. So sometimes, when you see a live site, you come to a dashboard and you don't see anything. And you go like, why isn't there? And in half an hour or 15 minutes or whatever time it takes, you probably end up seeing, oh, there is this thing. But it's usually up to date. And it's the only source of information at this point to understand what's going on when the platform issues are. So today's session, we're going to focus on the middle category, where the self-help is possible. This is where you can do something yourself and try and figure out what could be the root cause and things along those lines. Okay. So what you can do today with Azure App Services, you cannot RDP to the VM for obvious design reasons. Your application cannot emit ETW. You don't have access to VM or a site ETW, or you can't install any MSI. And it pretty much makes you feel like cripple. But based on my experience working as a board, I always ask this question: when things are not working well, even if I give you the RDP, what are you going to do next? Right? Are you going to install a bunch of debuggers? You're going to generate memory dumps, and what's next? How are you going to make sense out of it, right? So just giving RDP is not always enough. And we thought we should try and do a prototype of trying to build the intelligence around this data gathering and parse this data based on the experience that we've gained of supporting our customers for over multiple years, and provide some prescriptive guidance instead of just, oh, here's the RDP, go figure it out yourself, right? And that's what this project basically started with. We started this project calling that as a no RDP project, and it is still in preview, but we're trying to make an attempt where we want to take a next step when an alert comes in. What do you do next without just restarting or engaging somebody or calling support? Okay, so what all tools available? Everybody knows about HTTP logs, event logs, .NET detailer message, field request tracing, application logs, PHP logs, management portal, App Insight, Kudu. How many of you are aware of Kudu portal? Right, cool. How many of you have used Kudu or any of the other troubleshooting tools to troubleshoot your web apps? All right, perfect. There's quite a bit. Great. And then we have partner solutions like New Relic and Zen Zero, which we announced this week for profiling PHP. So I'm not going to go through the most obvious ones today because it doesn't really help. Like, HTTP logs, for example. If the site's not performing well, getting exception, it tells you, here's the page 500, this status code, done. What's next, right? I mean, what are you trying to tell me, right? So it is a good start. It is a good start. It tells you, here's the page that failed. You can't go to your dev saying, oh, here's the page that's giving 500. He's going to go like what, right? So what we're going to focus on this little part is what we call a support portal or support site extension, where we try to automate some part of it. All right, so this is where we start jumping into demos, and we'll be spending the rest of our session doing demos from here on. Okay, so number 8. There we go. Okay, this is my management portal. I've created this nice little site called the Buggy Bakery, which is a nice little bakery application. Not because I love to sell cakes or I like cakes, but it resembles that troubleshooting should be a piece of cake too, right? And we'll try and find out how that works. Okay, so let's see what the Kudu portal looks like for those who are not aware of. Every single website has a special endpoint called SCM, and that can be appended by the site name .scm.azurewebsites.net. When you browse it, it takes you to this beautiful portal, which is sort of your RDP into the machine, right? It gives you the environment variable, etc. But when I go to the debug console, and when I say CMD or PowerShell, it makes you feel like home. Like now, this is where I feel like I'm in a server core Windows. I can do X, Y, Z. You're still running in a sandbox, but which is great. At least it gives you something to work with. You got a process explorer, which is like your task manager. And you'll notice there are not too many processes up here, right? There's just WTWP, and then there's another WTWP for the Kudu site, which runs in a separate process. WTWP is the one that hosts your application. There are not many processes. It's not because there are not many processes running on the VM. It's because you're running inside a sandbox. This VM can be hosting hundreds of sites, but each site cannot see any other, right? So the only thing that you can see, because you came to the Kudu endpoint of this bakery site, you can only see what it owns and all the child processes from that point on. Now this is typically similar to Task Manager. You can do a bunch of cool things. Look at the modules, look at the handles, threads, environment. Even giving this is usually not enough. I can see CPU or memory going high, and what's next, right? It's always hard. You can kill the process. You can download the memory dump to debug locally if you know what you need to do with it. And then there are a bunch of site extensions that Kudu allows you to play with, right? So this is Kudu in general. There is one specific site extension that I want to talk about. So let's just switch this here and switch to our real demos from this point on. Like, there's always the situation, like, your website's going to have a really big event, and you want to have an insight into what is going on, right? A monitor of live traffic that can be moved every few seconds and whatnot. It's first start to peeling the onion, keeping an eye on your website. So for this scenario, let's go back and see what we built. So from Kudu portal, if you click on tools, and if you click on support, it will do a redirect with a single sign-on for your site. A little bit, it should come up to the support portal that we have, where it will list out all the sites that you have under the account that you logged in as, right? All the subscription, all the sites, etc. And the first thing that you see right off the bat here is observe. So what is this observe? Observe is basically sort of a big data solution that we guys built, where we analyze your logs every few seconds and try and categorize what is success, what is failure, what is coming from some different instance, aggregate them together, and start displaying them live, right? And just to show you how that looks like, I'm going to go and just cancel out of from here and start a load test on a site. So we just started the load test. I'm going to go and switch to that site from here. And I think that site is in this subscription. I will switch to, this is a specific site. And we'll just basically switch the process to that guy. So it will load the data in a little bit. And we saw the load test has started. In about 10 seconds, you should start seeing the traffic that is coming to your to your VM right there, right? So within 10 seconds. So whatever is happening, we're aggregating what the errors are coming, and you're basically showing you right here. So it's getting 3 requests per second. It's ramping up slowly, and out of that, what's failing? Next 10, 86, 25 the failure. So this is something you can keep in your office. You can monitor when the live event's happening. It's a great start to start peeling the onion, and something bad went, right? And then you can start using what you need to. The beautiful thing about this is, like I said, we do the aggregation across different VMs and all the stuff for you. You don't have to do it yourself. You can switch by different host names. So SCM is a different process. The old requests that I've been sending to the Kudu site are being tracked here. But if I go to the actual site, they're here. If the site were to be behind a traffic manager, I'll show you in a little bit. I have a site where there's some load going on. Here, these two sites, level 3 north and south, are behind the traffic manager. I'll switch to that. I went to the north, and I'm running a load test to a traffic manager endpoint, which is here already. And as you can see, everything seems to be going good. It's getting 444 requests per second. Now I can monitor the traffic for all the host names. If my site has multiple host names and I want to monitor for a given host name where the traffic is coming from, I can pick and choose. If I choose this, nothing's going to show up. If I choose this, nothing's going to show up because no one's browsing with that. The only thing that's been browsed is this host name. That's what my load test is doing, right? And it's fantastic, right? So if I go to level south, right now I've been assigned to this site, so I probably won't be any traffic at that point from there on. So yeah. I'd like to wait till the end so we can go through all of them, right? So this is a good start. So first step on observing what we can do. And as you can see, there's an obvious transition from observe to analyze and to mitigate, right? So to see what analyze can do, let's move on and talk about a scenario. Right? So basically now you see in your website is all of a sudden performing slower. It's giving an exception. It's giving an error. So what do I do next, and how do I troubleshoot? What do I have available for that very specific thing? So I'm going to go back to my Buggy Bakery site. And let's change the scope here again to that guy. As you see, once you logged in with this, it knows all the subscription, all the sites. It's a one single place for you to start monitoring stuff from here on. Okay, so here's the Buggy Bakery site. I'm going to browse to it. It looks fantastic. And I'll try and order a carrot cake, right? And you see it's spinning. And I want to find out what is going on, why this is spinning. That's the next step to try and isolation. So there are tools like FREB. How many of you are aware of FREB, or failed request event tracing? Okay, cool. So I'll show you one little trick. So it took 15 seconds, but it came up. So if I go to my site, go to all settings, and say diagnostics logs, and you'll see this little thing here called failed request tracing that I've turned on for FREB. Once I turn that on, I can actually go and set up good rules in my web config file. So I'm going to go to the kudu endpoint. By the way, yeah, you can, when you click on the site, you can see where it's, what mode it's running in, what location it's in, and then go to kudu from here on. So I'll go to my kudu endpoint, go to command prompt, sites, www-root, and I'll open up the web config file. And you'll see I have a rules basically paste to say, trace everything in order one path. Put all the providers, trace all the providers, and the failure definition is status code 200. You can have a failure definition of a time taken. You can say, if this page takes more than 20 seconds, then only trace it. I'm tracing it right now for every single request in that, and then there's another rule that basically says trace for 500 and whatnot. So since I had this turned on, and I was tracing the order one page, which happened to be this specific order one carrot cake, I can go to my support site, click on Analyze, and I see a FREB log here. I will refresh them. It takes a little bit to get the logs back, but it came up right away, right here. And when I select this guy, you'll see there are a bunch of information here. The time the trace was generated, what was the URL, what was the verb, what was the status code, and the time taken. I can filter them based on URL, time taken, whichever field that I like. But if I look at this guy and scroll down, here's the report that I got. It says, here's the page that I was tracing for status code 200. That was the trigger status. If it was 500, it will give you 500. If it was time taken, it will give you time taken. And it says it took about 15 seconds to respond. Great. If I go to compact view, I will see the entire pipeline of .NET. What happened to that request? Which all module touched it? What was the request body? What was the request headers, right? And things along those lines. And I can start looking into where it spent most of the time from the time taken, but I can do a little trick here. Go to request detail, and there are different views. I will go to performance view and sort. Aha, it took 15 seconds inside the ASP.NET pipeline leave, right? So it was spending some time inside the ASP.NET pipeline processing. If I click on view trace, it tells me, yeah, I spent time inside this lazy module, right? So it's great. It's a gimme module that I wrote, but it's a good start for a dev. Like I said, you don't have to tell your dev how to fix things. You have to point him to the right direction, and he and she will know what he's changed or she's changed, and will know from that point on. I'm simply in this lazy module. I'm just sleeping for 15 seconds, and that's that, right? It's a really simple situation here, where on the order one page, I sleep, just to prove a point. So now we peel the onion to one more layer. In the observe, we see what's going wrong. Over here, we can start peeling one more layer. And then there are other things and tricks that you'll end up doing when you want to troubleshoot even more deeper, and I'll get to that in different scenarios. One more thing I want to show you guys is the event viewer. How many of you didn't know that we had event viewer for Azure Web Services? There is event viewer, right? It's just not visible in the portal, and it's not there. But I'll show you what it looks like and how to get there. Again, support portal. I go to event viewer, and here it is. What I do here is basically grab the event logs that are emitted from your application within the sandbox across different instances, combine them together, and present in one single view. Here you can filter them just like your Windows event viewer that you're used to, event ID, whatnot. Here's another example, really something stupid that I'm doing with the pair chart. Trying to order that, it fails. And go back here, refresh it, and in a little bit, I should get the event here, right? This is the event that happened, and it tells me unhandled exception happened in .NET because .NET logging is beautiful. And it tells me here's where the game, and I misspelled stack. I called it stock, which is fine. But yeah, it was on a stock because I was doing a fib div in the wrong way. Okay, but it gives you a call second, your typical .NET event that you want to go troubleshoot. So event viewer is present for every single site, and it will do the aggregation from all the VMs. All right, simple stuff done. Let's move and see what's next. Okay, so here's always $1 million question, right? Now, why my site spinning? Usually it's a perf issue. You click on one page and it's spinning. Some customer reports say, hey, I'm trying to access this application or this part, it's spinning. You get on the machine, you try and access the same page, and it's coming up fine for you. What are you talking about, right? Now, how do you troubleshoot that? It's always hard. It's always hard unless you know what exactly is happening inside that process that is serving this request at that given time, right? Having that lightweight snapshot, right, will always help you. You can't really attach a debugger. You can't do FI debug. None of that works, right? The only thing you're going to get in this situation is probably some alerts coming saying, hey, there's a slow response for the one-so page for X number of people, and there's that. All right, let's see what we can do about that. Okay. So over here, and I'm right now going to go and manually start showing some part of it, but this is diagnostics part, and this is the beef of all the things that we've been talking about. Right now we're starting to get into something more aggressive on a diagnostic side, right? So diagnostics, we call that as a diagnostics as a service, where right now what we allow you to do is configure what is important to you for that application. Is it event logs, memory dumps, which is the WTWP process that is hosting your application, HTTP logs, or PHP. This might be a PHP application. You don't care about the .NET, and it can be PHP, right? So for this one is a .NET app, so I go and set the configuration to memory dump. This diagnostics as a service is nothing but a little web job that we call as a dash runner. Is a little warrior, man, right? So what this guy does, that it knows based on a setting what are you asking him to collect, and he knows what to do with the data I just collected and build the report and try and make sense out of it, right? And the reason I call him a warrior, because this is a feature that you use under a really hostile situation, right? When things are not working well in the VM, it's not something configuring this nice feature, etc., right? You're setting this guy in there when the memory is spiking or CPU is spiking, the situation is really bad, and you tell him, okay, all right, I'm going to go send you in there. Get me the memory dumps, get me this log, move them over here, analyze it, kill everything out there, come back and tell me what happened, right? Fantastic. Most of the time, it works great. But there are situations where this warrior will need help, and if the war zone is really bad, it might not work. Eventually, I do plan to make this guy into Master Chief. We'll get there, but he's not there yet. So this runner, basically, right now, I'm telling him to go and collect the memory dumps because that's what I care about. Again, one more thing I want to throw out, that this infrastructure is completely extensible. And let me talk about that after I show you what I mean, so it makes more sense. Okay, so let's see. My app's spinning slow. I'm going to go back, and I'm going to reproduce a situation. I really hate chocolate cake, right? So that's why I named them as the deadlock cakes. And I'm going to try and order chocolate cake twice. Here, we'll click on this once. And let me just try and get this guy here. one more time, really quick before I lose the situation. But here, okay, this seems to be spinning, right? And now you're wondering, why is it spinning for whatever reason? And if somebody else goes to a different site, a different cake or whatever, it will keep on working. What do you do in this situation? You can come back here in this site and just click on a single button that says, something's wrong, diagnose now. So this is going out there and just submitted a session based on the settings that you provided, and it started collecting the dumps, right? If you click on the Diagnose Now button from this point on, it's basically going to go through all the VMs that you have inside your site. So if your site scaled to 3 or 4 or 5, it's going to make a round, number 1, number 2, number 3, number 4, and just go get the data and try and make sense out of it eventually when it runs, right? So here you see it finished generating the memory dumps and is analyzing at this point. If I were to go back to the Diagnostics console and the Process Explorer, I should be able to show you what I meant by the extensibility. You see, it's calling a dump analyzer, a shell script, and this host, and a Perl script that's been running. All of them is running as a child web jobs, right? So they should finish in a little bit, and and it's done, right? So I can basically now expand this. This is basically the whole memory dump of the process, and it built the report based on what it found in that process dump. So I'm going to go and click on that, and you'll see it found a bunch of things and has recommendations on top of it, right? So before I started the demo, I had changed the configuration on the site, so it knows that there was a config change that came in that had caused the shutdown of the app domain, which is fine. But here, if I start reading into all the recommendations it's giving here, and it tells you, and wherever possible, it gives you a link to an external location where it talks about what happens when these sort of situations occur and how you troubleshoot. But over here, you can see, it says the 2 threads are basically waiting to enter a .NET lock that has been held by 34, and a bunch of guys are trying to get into it, and 2 client connections have been running for a long time. So if I click on that, it will tell me which connections. Yes, I've been trying to order some chocolate cake. So if I go back here again and click on the thread 34 that's holding the lock, it gives me a native call stack of what is happening on that thread alongside with the management right here. So it tells me method B is holding some lock and it's trying to enter a lock, and then other guys are basically waiting on that, right, and 28. So if I go back into my code and try and see where the lock B has been coming, here, the CC method A is basically grabbing lock A, sleeps for 4, and tries to grab a lock B. And method B is trying to do lock B and trying to grab a lock A, right? So it's basically true in a classic deadlock situation here. And even though it looks very simple in the code perspective, but the tool has an ability to look at these, read the call stacks, and identify the situations and start pointing you guys in what you need to do, right? If you were to show this report to the developer who wrote the code when they were spinning, he will exactly know what is wrong and how to fix it, right? Besides those situations, as you saw, it showed you the requests that were in flight, how long they've been running for, the GC usage, and all the other cool stuff. So I'll go through the report one by one slowly here. It gives the name of the machine, what the architecture is, what your top CPU threads are, which threads are consuming the most CPU, what your CLR information is, what threads in that situation slot they are in, what HTTP contexts are available. This page has been running on thread 34, this 36. If you click on that, it takes you to the call stack of that. And this is very, very lightweight. What has happened in this situation is basically you just dumped out the process at that given time, and the process was broken for that moment. And as soon as the dump was finished, it's resumed the execution. So from the client perspective, he or she just experienced a very slow delay in loading the page, which was not loading to begin with, right? So here, and then it gives you all the .NET exceptions that are not been garbage collected yet, and things along those lines. It gives you database connection strings, a lot of beautiful things, right? But at the high level, it tries to tell you what it found and what can be done to try and troubleshoot this specific issue from this point on, right? And this all knowledge information has been built based on years and years of troubleshooting with the actual customers. When we understand and identify a specific issue, we try and automate that rule into the engine and deploy inside this. So next time somebody else sees it, he or she can basically try and figure it out what went wrong, right? So this is a constant journey. We keep on updating these rules as we find new patterns. we keep on pushing them into it, right? So eventually we'll get to a point where we've addressed 90% of the issues that are specific to app service, but that's a great start. Okay, so this page finally failed, which is timed out afterwards. So it's a great scenario, right? So if I go here and close this out, and yeah, these are my sessions at this point. Great. Let's see what's next we can do. All right, so this is great. .NET, it works great with the .NET. What if I have a PHP application, right? Can I use the same tool for PHP? So let's try and see what is if I have a PHP site. I'm going to go and basically change the context to that specific guy, right? And it's a very simple WordPress, like the slide said, right? I browse to it, it's spinning. It's a stock WordPress installation. I can't understand why it's spinning, right? And I'll try and use the same technique that I did and basically get the data for that too, right? So we'll just go and browse to it a couple of times. Okay, and then I come back here, go to Analyze, in the settings, I should have just PHP because I ran the demo for this before. Yes, it's just PHP. So as you can see, its setting is per site. It's not tied to your global set or any of that. And again, I can come here and just click on Diagnose Now, or I can go to Metrics tab, and I'll talk about that in a little bit, what this exactly is. But I can see there's a specific instance. I only run on one instance right now, so I'm going to go and diagnose from here on. When I click Submit Diagnosis from this point, what I'm doing at this point is basically saying, don't run the session on all the instances that I might have on the website. I just care about this specific guy because it doesn't look right. So I'm going to go and initiate on that instead of taking the whole site down, right? And I'll show you what it looks like when we scale to 2 of them. But they should have kicked off the session here for PHP. It's done. And PHP, fortunately, is a very lightweight process for us in a debugging as well. We do not try and dump the PHP process out because we realize that on a given site, there can be hundreds of PHP running, and dumping them all out is insane. So we, in flight, basically grab the snapshot of the process and run the analyzer on those PHP and build the report, right? So let's see if this guy caught anything useful. So if I click on this, so I see there were 4 processes running, right, already, and 3 of them were running the index ESP page, and we can go to them one by one. So I will click on this guy. It tells me, again, the environment variable with system uptime, the process uptime, debug session. It gives me a native call stack from the PHP. What it's trying to do, it seems like it was trying to do some plain file unlink operation, trying to remove some file and delete a file. Okay, that's interesting. And it tells me all the modules are loaded inside the process, right? Even this is stock WordPress, people usually have modules installed. It also tells me the handle information, the CPU time. But here's the money part. Here's the PHP call stack. It tells me what happened to the page. Main was executed twice. Here's the line of code. Do action. CAPTCHA. There's a plugin called CAPTCHA. It's trying to do a cleanup, right? So that could be part of the reason why the site is slow. So what I can do from this point on is just go to the site, so go to Kudu endpoint, debug, CMD. Okay, I'm going to site, www root. I think it's the WP content, uploads, CAPTCHA. And just because I know what this plugin does, is basically this guy tries to create a PNG and a text file on every single request that comes in and tries to read and parse it on every single request that comes. So if I go and say delete all these files because I don't need them, so delete star PNG. I'll take a little because there are tons and tons of them. Okay, but yeah, you get the point. I'm going to go ahead and refresh this and try and delete it one more time afterwards. And once I delete it, the performance of the page should improve dramatically, right? So let's try it one more time because there's just way too many files in here. WP content, uploads, CAPTCHA. Okay, delete the .txt. Okay. All right, let's do delete star.png one more time. Because the process running still might be in use. Okay, I'm going to go now and try and do Control F5 and see if performance improves a little bit. And it did, right? It was much better than previously. I can go and delete the list that is left, but you get the point, right? So it's usually helpful, not only in a .NET space, it does good things on troubleshooting PHP as well. Again, so I'm going to go and close all the stuff out here before we move on to the next one. Yeah, it also gives the PHP request information for that specific time, the core global variables, and if there was any last error that was happening. The permission denied was trying to delete it. The process in itself was getting a permission denied as well. So anyways, you guys get the point. All right. One thing I want to show real quick, in the interest of time right now, I'm going to skip through, but I can show if your subscription or a site that you're running has a MySQL database, you can go to Analyze tab, and we have an integration with ClearDB. So if you click on this ClearDB tab, it tries and calls the ClearDB database and tells you what connections that are running. I don't have any load tests or anything going on here, but it tells you open connections, if you've done any violations or slow log entry, size of a database, how much has been used. So it's usually useful when you're troubleshooting a slow issue with Burf as well. All right, let's move on. Okay, so this is all great, right? You know, I can do a bunch of things when site spinning or slow availability or exception, but what if these things are happening in the middle of the night? What if it's happening to one or two customers, not everybody, right? When I get a call in the middle of the night, I try and see the site's up and running, but some customers complaining, you know, I don't want to do this. I want you to automate this automatically. There are some set of customers who really don't care about trying to find out what is going wrong, as long as you can fix it, right? You just just restart it. It takes a restart, just do it for me automatically, right? And that's where the mitigate comes into picture. That we call as a feature called auto healing. And I'm going to show you the UX that we built for that recently. This feature did not have a UX up until a few days ago. And it was only configured via a web.config file. But now it does, which is good. So let me just go back to my favorite bakery again. All right, and so mitigate. Over here, I can set auto healing rule based on certain conditions, right? So now I know that when things are not working well, I want to kick off a workflow instead of me coming in and trying to get data automatically, right? So I'm going to go ahead and say, turn auto heal on. And when I do, you'll see there are a bunch of situations that I can capture. I can say max requests, right, and add a rule for that. And say after number of requests, in certain interval, take an action. This is a vanilla scenario. If you know your app after serving 1,000 requests is going to be crashing or doing memory leak or whatever, might as well just, if it serves 1,000 requests in 30 seconds, set a rule and take an action. So let me just go back to this again. Slow requests, that's the second scenario. You can define number of slow requests in a given amount of time frame in a given time interval. So say if I'm getting, say, 30 requests taking more than 30 seconds to serve, in the last 2 minutes, there is definitely something wrong. Help me out, right? So I can go and say, set a rule saying 30 requests take 60 seconds to serve, in the last 120 seconds, there's something wrong. The moment I added the rule, it tells me, go and set your action. Okay, what are all the actions that we support? You can log an event, you can recycle, or you can run a custom action. The default custom action is you can run the DAS runner that we talked about, DAS console. And what this guy does is one of my favorite ones, and we'll see the demo for that in a little bit. But what this guy does, he says, you know what? When this condition is hit on the VM, not the entire site, right? So you can have 5 workers running, and one of them is acting bad. And that worker is the one that's going to send the signal that I'm the one that's hitting this trigger. It wants to run a custom action called DAS console with collect, kill, and analyze. Right, so let me just show you here. What this guy does is I'm going to go collect the data. I'm going to kill the bad process and recover the situation, and then I will analyze. So if this situation happened in the middle of the night, you basically collected the data, recovered yourself automatically, and in the morning you have the report ready to help you understand what went wrong, right? So we'll see how this works in action real quick. So that's slow requests. I'm going to go and then status code. Again, you can do number of requests that gives me HTTP 500, sub-status code, 130 status codes in this interval, take an action, which is, again, very, very useful. A bunch of customers use this situation as well, but majority of them really like the slow request because it's a good way to understand or detect the situation. Then there's one final one, which is my favorite one too. I'm going to go and say that one. This is the memory of a private site, right? Private byte. So most of the time you end up getting customers, right? When you get a website in a VM, they try and put as many websites as they can, and there's always this one bad guy that takes up all the memory and affects all the other guys, right? So, and it's hard to basically go and knock them out, but you could basically use this tool to your advantage and see if I can reproduce the issue. So I'm going to go and say if this guy 500, if it goes above 500 megabytes, I want you to take a custom action of doing this, right? I'm going to go and just basically say update. The rule has been updated. I'm just going to make sure I don't have any more rules. The only rule that I have is if the process goes above 500 megabytes, take a custom action of collect, kill, analyze. All right, so we go back to our famous bakery application. And close this out. Close this out. I'll keep this. Keep this. This doesn't hurt. Okay. So I browse to this application. And I'm going to load test one specific page where I've created a leak, and I'll walk you through what it looks like. So before we hit it, let me just go back here in Process Explorer, try and show you what it looks like. This is our guy, WTWP, right? He's sitting happy at 63 megabytes, 41 thread count. Everything looks good. I go back here, try and reproduce, sending about 1,000 requests using tinyget to an order 3 page. And what you should see in a little bit, if I go to Analyze and refresh, a couple of times probably, bam. The load test already triggered the site to 500 megabyte. It started the collect workflow for me. I didn't have to do anything at this point. Everything's working automatically, right? So I go here, refresh this, and I'll see this guy's probably gone bad, really, really bad. Yeah, it's at 1.5 gigabyte. The DAS console kicked off. It knows what it needs to do. It's going to go and collect the data. As soon as it's done collecting, it's going to go kill the process. So the next request is don't experience from this. It will build the report and tell you exactly what went wrong in the morning or whenever you're ready to look at it and try and fix it. Okay, so it takes a little bit, right? Because it's trying to dump a 1 point some gigabyte of data. And that's why I say it's a little warrior, right? It does wonders even in the hostile situations. But when things go really, really bad, it's a 2 gigabyte right now. It might need some help too. And I'll show you how to help him out in a little bit. But while that's working, I'll show you the one that I had already created. Hopefully this is the different one that we created just now. Maybe this is it. Let me see if this is it. Yeah. So I had previously ran this, and while we're waiting for this to finish, I'm going to go and show you what this looks like, a report. So over here, it tells me thread 29 has kicked off a garbage collection. Fantastic. It's a telltale right there. So if I start looking to manage code, it tells me leak context right here, right? And it's leaking to a really, really bad point where it has to kick off a garbage collection. The CPU should be at 81% because GC is kicked off. Here's the beautiful part. Again, it tells you what you should be doing, how you should allocate, but beautiful links wherever possible. But here, I want to see what is consuming the most memory. I click on that. It tells me system.web.http context is taking. That array is taking about 1.13 gigabytes. There are 6 objects of those arrays right here. And it tells you, again, what are in the finalizer queue, what is on your large object heap. Those guys are on the large object heap, right? So the only way it's going to get collected when the Gen 2 is being got a call. And Gen 2 will only collect that guy if it's not rooted, right? It doesn't seem like it has been collecting because it seems like it's been rooted. So if I go back to my code and try and see what exactly I'm trying to do here in a leak context. Here, leak context. Let's go to the definition for this guy. Here, I'm trying to add the contexts of every single HTTP request 500 times into history object, right? And once that's done, I go to the definition for that right here. And see, this is static, right? It's going to be rooted. It will never be collected, right? But people end up doing these sort of mistakes, right? But the point is, if you show your dev This specific information is enough for them to take it from that point on, right? Imagine trying to do all these stuff when the things are not working well in production, trying to attach a debugger. No, man, it's usually not going to work. I mean, if it's spinning, you bring the dev out and say, see what's happening. He's probably going to say, I don't know, right? It didn't happen when I was writing the code, right? But when you show him this, you know exactly what's going on. But it gives you all the beautiful information possible. It tells you what you should be storing in this thing and what not. And we're trying to automate things as much as we can. So we should go back here to Process Explorer here. This bad guy should have been gone by now. Yes, it is. I don't have the always on turned on, so that's why the new process hasn't kicked off. And this should have finished, and it has. So if I were to click on this, depending on when it triggered, yeah, I was lucky here too. It's telling me thread 36 is doing this right here. There's a bunch of things, and it's a high CPU because the GC has been kicked off, and the exact same thing, right? So it works every single time, and I recommend you guys try this out on different situations wherever possible, right? Send the warrior out into the VM. It will do wonder when it works. But when it doesn't, I'll show you how to recover from that situation as well, because it probably would have been a very hostile place to begin with. Okay, so let's go back here and let me show you real quick how do you kill or get rid of that situation. So you go back here, not to this guy. Let's close this, close this, close this. This is the guy, yeah. If you got enough time. You go to Data folder, DAS, and this is where your logs, reports, and sessions are, right? I can go to Logs folder, and based on the date and time when it was executed, I can download or whatever, I can go delete from here. You know, yes, I have a feedback for myself as well. I'm going to put the delete button right next to the logs so you can get rid of it from that point on. And yeah, but for now, you can just basically delete these guys from here on. And the moment there's a folder called session, which has active, complete, and collect logs only. The collect log only one will be only activated when the DAS console auto heal kicks in. Active one will have the sessions that are running right now. Complete is the one that is done. You can delete all these sessions, and the moment you do that, it will not list into your session. If you ever see the DAS runner or the collection spinning that never comes back, because it's usually very fascinating to watch that spinning because it's about to tell you something. Sometimes it might not because, like I said, the VM situation was bad. You can always go back and scale up and down the VM, and it will restart the thing, and that's when you survived or basically saved them from a bad situation. Okay, real quick, and the matrix tab that I didn't show you guys, but if I go back here to Buggy Bits and basically say scale to multiple instances, save. Okay, that's done. I'm going to stop and start just for sanity because the scaling takes a little bit. Yeah, it does. It's not done yet. Stop. Start and browse. Okay, so that's coming up. So now I should have 4 instances. But if I go to Matrix tab and try and refresh this guy, in a little bit, I should be able to see there's 4 VMs that comes up. This is different from the Azure portal because now what you're seeing up here is that site-specific CPU memory on that instance. What you see on the Azure portal is your combined CPU memory usage for that given site. Over here, you can come in and see what is specific to that given site, right? There's a CPU memory we give, the HTTP statistics. Again, this will give you, the HTTP statistics will give you how many requests has been served, failed on that VM for that site instead of the entire aggregation. This is a great way to find out which VM is busted, which is taking how much traffic, which is not doing well, and where I need to invest most, right? It gives the network traffic and all the good stuff. You see 4 instances there. You can sort by 1 hour, 24 hours, 5 minutes, whatever tickles your fancy over here. And also we give you ability to restart WTWP on that VM, right? Because when you go to the portal and try and start the site, it's going to take everything down and restart all the VMs and everything. Over here, you can just say, you know what? I want to restart just the bad guy on that VM. And when you do that, it gives you 5 seconds to change your mind. Too late. And it will kill the WTWP, and you'll start the new one. Right? Great. Fantastic. So that's how you can do per VM. You can diagnose per VM as well by looking at the memory, CPU, CPU stats, so you get a good idea on which is bad, and instead of doing a hammer of all the VMs, take one out and take it from that point on. Okay, so we are running a little bit slow on the time. I want to talk about one last thing. We covered that situation. The last thing is basically this, right? So, is what do you do when all of this fails, right? You know, the platform issues we talk about, we're on top of it, and you tried all these things, and you still need help. What do you do in this situation, right? How many of you don't like paying for support? You think support should be free? Yeah, you're one of me, right? How many of you think it's ridiculous to pay for support to report an issue for live site or a service issue? I think everyone, pretty much, yeah? So we try to solve the second part. You know, we're working on the first part, and eventually get there, but we try to solve the second part. If there's a live site issue, and you really don't want to call a support or don't have a support contract, and you really want to report something to somebody who's listening or monitoring, come to support portal, click on need help, right? Select the subscription that has issue, select the site that's having an issue, what category of issue that you're seeing. Well, you'll be more descriptive and then help me, but yes, you get an idea, and you send. You send an email, and I'll show you a little bit, and we'll give you this little 911 disclaimer. If there's an emergency, please call the support, right? Don't wait on us or whatever, right? But at least when you do this, there is, and I'm going to show you guys my inbox just to prove that, yes, it works. The email gets sent out to my servicing team. Now, people who are actually monitoring the service, whatnot, and in a little bit, you'll see that here. The email came out. And there are a bunch of people monitoring it, and we'll reply or basically start working on the issue right away. And let's see if anybody replies while we got 5-10 minutes to see if anybody wants to see into it. Okay, so let me see, go back here. But yeah, that one way to report an issue, and you know, we take that very seriously. If it's a service issue, we'll work on it right away. But if somebody's asking me, hey, how do I code this, right? I mean, we're going to nicely tell you, here's the support, right? And eventually we work on that part to make that work. So I think, you know, I have covered the majority of the scenarios that I want to talk about. There's more that we're building. But at this point, I think, let me just go back and make sure there's no more slide. Yeah, there's an eval that we recommend. You know, please give us a feedback. Tell us what you like to see. We'll like to build that for you whenever possible. And that's that. Question. Thank you. Yes. No, I'll repeat the question. Excellent question. The question is, sorry. Right. Excellent question. The question was, how does this diagnostic as a service compare against things like App Inside and things along those lines, right? So the App Inside is basically something that you work into. This basically, on the other, it complements App Inside, right? Not every customer will have App Inside or any of that instrumentation running for their code from get-go. Even if it's running, it might not be completely or truly optimized to basically capture all different situations, right? What we're trying to solve here is that there is one very specific situation where everything's running in production, and you want to have a very lightweight snapshot of what is exactly going on without installing any tools, without having any tracing or anything running in your application, just to go at that specific time. Right? So the App Inside and everything works great, and the Zen profiling and everything works great when you're doing a per request troubleshooting and trying to find out what happened to this request and things along those lines. The other part of your question was, how does it work with the multi-tier applications, right? And we're trying to solve that one by one, because what this does right now, it gives you a snapshot of your web processes. It tells you to a point that, you know, if you're stuck on talking to a database, it will say, I'm making a call to a database, and I'm waiting to get the response back. It will not tell you what exactly is wrong at this point onto your database, on your query. We try to solve that step by taking a further collaboration with the ClearDB that you saw, where they have a diagnostics API that we call, that does a connection test, that does tell you how many connections are open, if any violation or whatnot. So they try and provide that information. But we rely on all the other environment to basically help us participate into this this project to eventually have the full end-to-end solutions like that you talked about. Sure. Right. No, there is Yeah, this is basically whatever's on the machine that you take in to take a snapshot at that point. If it happens that you basically upload the agent, write some scripting on your client-side browser, and then get the data and then instrument from that point on. Right.
So this one does web apps. And web apps are now rolled in with all the app services.
Right.
Will this also work with the web API, the other ones?
That's correct, right? So all the other app services that are rolled in are basically using the same platform, right? So they will, and like I said, I briefly touched to a point that this framework is extensible. Today, if you have an application that is your own, or CMS application, you're writing your own logs, and you know what exactly you need to do with that log. If some error happened in the log, you want to tell your client, do XYZ, you just write the collector, you write the parser, you upload it in your config file. I don't have a UX to show how to do that, but you upload your config file, and you are part of the system now. Right? So now you're basically participating in this framework. All you have to do is write the collector. You know where your logs are going. You know what the entry in the log means. Write the collector, write the parser, build the report, and you can pretty much plug and play in this. Right? So every mobile app or anybody else, they will eventually, if they want to, they can participate into it. Write a node collector, node parser. There's nothing stopping you from doing that. And then you can take advantage of these auto-healing triggers that we talked about and then trigger your analyzers and collector instead of the one that are in the box. Good questions. Thanks. All right. Thanks. Oh, there's one more. Sorry. Yes, okay. Mm-hmm. So it's a good question. So the question was the auto-healing rule that I was setting up, do they go inside the web config? The answer is no, actually. Previously, when we didn't have the UX, we allowed you to put those rules manually inside the web config. When you do this from the UX, it goes inside the application host config file. So if you were to set the rule using the UX and also set one with the web config, the one in the web config is going to take the precedence, right? So this actually allows you a flexibility of running multiple custom actions. Today, with auto-healing, if you were just in a web config or app, you could only run one custom action for multiple triggers. But now you can have few triggers and a specific custom action in your app host. And the one that is important, you can have it in web config. So now it will monitor both of them. And you get a flexibility of doing more advanced situations if you need to. Yeah. Next question. Question. Different. So question. The question is, does Kudu work with the RBAC? The answer to is today, no. You need to be a site administrator to log on to the Kudu to perform XYZ. But like I said, this feature that we're building is, I like to call it as a prototype, as in preview. But we will eventually move this into portal. And when we do that, the RBAC scenario will come in, and where you allow people to do this for DevOps. Yes. Question? Sorry, can you please repeat the question?
Do you have command line tools, for example, instead of to go to the web page to type dot CSM dot, you use that for command line as an API to collect data?
Excellent question. So yes, there are APIs available, and I'll show you the command line available for certain scenarios, especially for the DAS one, the diagnostics ones. So if I go to say mitigate and help, it will take you to my blog where it talks about the command lines that is available right now, right? And Kudu does support a bunch of API things that you can do, restarting the process and calling things along those lines. But here, there's a command line that you can use, and and that's what I've been using for a custom action. In custom action, you could choose to run your own exe if you like to, but this is something that we pre-built in. Okay. All right. Cool. Thanks. Thank you.